Man, have you ever just gone outside on a clear night and looked up at the moon? It's just hanging there, this silent, giant rock, and it's been doing that forever. We've been staring at it since the first humans were walking around, telling stories about it, worshipping it, wondering what the hell it is. It controls the tides, it lights up the night, and it's the only other world we've ever physically set foot on. You'd think after all this time, especially after we landed there back in the 60s, we'd have it all figured out. But that's the crazy part, isn't it? The more we learn, the more we realize we know almost nothing. We only ever see one side of the moon. Ever. For all of human history, that dark side, which isn't really dark, it's just the far side, was a complete and total mystery. What's over there? Is it the same as the side we see? Is there something hiding? The imagination just runs wild with possibilities. People have talked about alien bases, ancient structures, all sorts of crazy stuff. And for decades, it was all just speculation. So for decades, the moon race was a two-horse show. But then, quietly, another powerhouse started gearing up. China. They weren't loud about it at first, but they were incredibly methodical, incredibly focused. They named their lunar exploration program Chang'e, after the Chinese goddess of the moon. That alone tells you something. It's epic. It's mythological. This wasn't just a science project for them. It was a matter of national pride. Their mission, the one that really blew everyone's minds, was Chang'e 4. Launching back in 2018, its goal was something no one had ever done before: land a rover on the far side of the moon. Think about the guts that takes. Landing on the moon is already insanely difficult. Now try landing on the side that's always facing away from Earth. You have no direct communication. To solve this, they had to first put a relay satellite in a special spot in space just to bounce the signal around the moon. It was a crazy complex cosmic bank shot. The rover itself, named U-22 or Jade Rabbit 2, was the little guy tasked with actually exploring this new world. It's not some massive dune buggy. It's a small, solar-powered, six-wheeled robot. It landed in a place called the Von Karman crater, which is inside an even bigger, more ancient impact basin. Scientists picked this spot because they thought it might have punched through the moon's crust. The whole world was watching, wondering what this little jade rabbit would find in a place no human technology had ever touched before. All right, so the Jade Rabbit 2 rover starts rolling around this place that no one's ever seen up close. What does it find? At first, it was pretty much what scientists expected, but with a twist. The ground was different. The rocks had a different composition. The rover's instruments started sniffing around, and the data it sent back suggested that the geology of the far side is way more complex than the near side. It's not just a mirror image, it's like finding out the B-side of your favorite record is a completely different genre of music. It makes you rethink the whole album. One of the first big discoveries was about the lunar soil, or regolith. The rover's radar, which can see beneath the surface, found that the ground is way deeper and sandier than we thought. It's like a thick blanket of fine dust, maybe 40 feet deep in some places, before you hit any solid rock. This tells us that the far side has been getting pummeled by micrometeorites for billions of years. It's a more pristine, older surface. It's like an ancient, untouched archive of the solar system's history. But here's where it starts to get weird. The rover's instruments detected minerals that hinted at the presence of material from the moon's mantle. Remember, that's the deep down layer. The theory was that the giant impact that created the crater it's in had dredged this stuff up to the surface. This is huge. It's like the Earth suddenly spitting up a piece of its own core for us to study. Getting a sample of the lunar mantle without having to drill hundreds of miles down is a holy grail for planetary scientists. It could unlock the secrets of how the moon was formed in the first place. So picture this. The U-22 rover is just doing its thing, methodically rolling along, when the mission team on Earth spots something in the photos it's sending back. Down in a small, fresh crater, there's a patch of material that just doesn't look like anything else around it. The official description from the China National Space Administration was that it had an unusual color and a gel-like consistency. Now, when a space agency uses a term like gel-like to describe something on the moon, everyone's ears perk up. What the hell does that even mean? They used the rover's spectrometer. an instrument that analyzes what something is made of by looking at the light it reflects, to study the weird patch. The whole world was waiting. Is it water ice? Is it some weird alien goo? The initial analysis was, well, a little anticlimactic, but also super interesting. The leading theory that emerged wasn't alien slime, but something almost as cool from a geology standpoint. Scientists now believe the substance is impact melt breccia. That's a fancy way of saying it's rock and dust that was melted into glass by the intense heat and pressure of a meteorite impact. Imagine a small asteroid hitting the moon at thousands of miles per hour. The energy released is so immense that it instantly melts the ground, which then cools rapidly into a glassy, shiny material. It might look like a gel from a distance, but it's really a type of dark, glassy rock. Even if it is just melted rock, it's still a fantastic discovery. Finding it inside a fresh crater means it's a pristine sample of a very violent, very recent event. It's a snapshot of a geological process in action. While the gel-like blob got all the headlines, China's next lunar mission, Chang'e 5, made a discovery that might be even more important for science. This was a different kind of mission. It landed on the near side in 2020, but its job wasn't just to look around. Its job was to drill into the moon, grab a chunk of it, and bring it back to Earth. This was the first time anyone had brought back moon rocks in over 40 years, since the Soviet Luna 24 mission in 1976. And these weren't just any rocks. They were from a region we'd never sampled before. The samples came from a volcanic plain called Oceanus Procellarum, or the Ocean of Storms. The rocks we got from the Apollo and Soviet missions were all super old, like 3 billion years old or more. They told us that the moon was geologically active early in its history, but then cooled off and became a dead rock. But the rocks Chang'e 5 brought back were different. When scientists on Earth dated them, they got a shock. These rocks were young. Well, young for a rock. They were only about 2 billion years old. That's 1 billion years younger than anything we'd seen before. This completely rewrites the timeline of the moon's history. It means the moon didn't just die off 3 billion years ago. It was still volcanically active, still had magma flowing, much more recently than anyone thought possible. This raises a huge question. How? A small body like the moon should have lost all its internal heat long before that. What kept it warm enough to have volcanoes? So China starts dropping these bombshells, a landing on the far side, weird gel, and rocks that rewrite history. How did the world take it? Well, the reaction was split, kind of like you'd expect. On one hand, you had the scientific community just buzzing with excitement. This was new data, new territory, new questions to answer. For a planetary scientist, getting a look at the far side's composition is like Christmas morning. There's been a lot of international collaboration, with scientists from all over the world getting access to the Chang'e 5 samples. It proves that when it comes to understanding the cosmos, science can transcend borders. But then you have the other side of the coin, the geopolitical reaction. For governments, especially in the United States, China's rapid success was a massive wake-up call. It was like they were cruising along, thinking they were still the undisputed champs of space. And suddenly they looked over and saw someone in the next lane not just keeping up, but pulling ahead in certain areas. This lit a fire under NASA and the US government, sparking what many are calling a new space race. Suddenly, funding for the Artemis program to return Americans to the moon got a lot more urgent. The public reaction was a mix of everything. You had people who were just genuinely fascinated by the cool science of it all, the mystery of the gel, the idea of a younger moon. Then you had the conspiracy theories, of course, people saying the gel was proof of aliens or that China was hiding what they really found on the far side. And then there were those who saw it through a purely competitive lens, like it was the Olympics, and were worried about losing the moon to China. It shows how space exploration is never just about space. It's a mirror reflecting our hopes, our fears, and our politics right back at us. Whenever you get discoveries that poke holes in our old theories, you get a whole flood of new ideas trying to explain them. Let's start with the young volcanoes. How did the moon stay hot for so long? One theory is that there were higher concentrations of radioactive elements like potassium and thorium inside the moon's mantle. Another, maybe more out there theory, has to do with something called tidal heating. The idea is that the Earth's gravity isn't just holding the moon in orbit. It's constantly squeezing and stretching it. We see this happening on moons around Jupiter, like Io, which is the most volcanically active body in the solar system. Now, back to the far side. Why is it so different from the near side? The leading hypothesis goes way back to the very beginning, when the moon was first formed, likely from a giant impact with the early Earth. In this scenario, the moon was tidally locked with the Earth very early on, meaning one side always faced our planet. The Earth at that time was still a molten ball of lava, radiating incredible heat. This heat would have kept the near side of the moon gooey and molten for longer, while the far side, facing the cold of space, cooled down and formed a thick, solid crust much faster. And what about the wilder ideas? Well, they're always there, simmering in the background. Some people still aren't convinced the gel is just melted rock. They point to the initial description and the massive effort to investigate it as proof that it was something more. And the far side? It being a perfect place to hide something from Earth-based telescopes is a conspiracy theory that will probably never die. While scientists are focused on geology, a part of the public will always be wondering if the real secrets are the ones they're not telling us about. It's just human nature to question the official story. At the end of the day, why does any of this matter? It's a bunch of dust and rocks on a ball 240,000 miles away. But it's so much more than that. These discoveries fundamentally change our place in the universe, even if it's just in a small way. Knowing that the moon had a longer, more active life makes its story, and by extension our story, more complex and interesting. It's like finding a whole new chapter in a book you thought you'd already finished. It reminds us that there's still so much genuine mystery and wonder left to discover, even in our own backyard. These findings are also a catalyst for the future. The new questions raised by the Chang'e Missions are the exact things that will drive the next generation of exploration. The new space race is pushing humanity to go back to the moon, but this time to stay. We're talking about building permanent bases, mining for resources like helium-3 for clean energy, and using the moon as a stepping stone to get to Mars. These Chinese discoveries are laying the scientific groundwork for all of that. Think about the technological leap required to land on the far side of the moon. That's a massive achievement that pushes robotics, communication, and artificial intelligence forward. The technologies developed for these missions don't just stay in space. They trickle down into our everyday lives, into medicine, computing, and materials science. Ultimately, this is a story about curiosity. We're a species that can't stop looking over the next hill. The moon is just the closest hill. China's missions have shown us that it's a hill with secrets we never even dreamed of. It's a reminder that the universe is way weirder and more wonderful than we can imagine. And as we continue to explore, whether it's China, the US, or some other country, we're not just learning about rocks and dust. We're learning about what's possible when we have the courage to venture into the unknown. And that is a powerful thing.